Hello, my name is Daryl Shirley, and this is my Physics 2 Lab 1 report. Introduction. This lab report will consist of the following sections: Introduction, Purpose/main idea, Fundamental physics principles, Preview, the experiment, the GlowScript code, the model, errors and possible explanations for those errors, questions, and conclusion. Purpose/main idea. The purpose/main idea of this lab is to observe the interactions between two charged pieces of clear Scotch tape and to approximate the excess charge on one piece of clear Scotch tape. Fundamental physics principles. The fundamental physics principles that will be used during this experiment are Coulomb's law and the equation for finding an electric field. The formula for Coulomb's law, as seen to the bottom right, is Fe equals Ke times Q1 times Q2 over R squared. And the equation for the electric field, as seen to the bottom left, is E equals KQ over R squared. Preview. During this lab report, I will show the experiment of the piece of tape experiencing the electric force from another piece of tape below it and calculate the number of atoms and excess electrons on the floating piece of tape. In addition, I'll create a model in GlowScript of the opposing charges exhibited by the tapes. I will also answer what-if questions as well as questions from the experiment. Experiment. During the experiment, the system was one of the Scotch tapes floating and the surroundings was the second Scotch tape in the Earth because of its gravity. To the right is a picture of the experiment in which one Scotch tape is experiencing a force upon it from the piece of tape below it. The initial conditions I noted were the K constant, 9 times 10 to the 9th, mass of the piece of Scotch tape, the length of the piece of Scotch tape, and the gravitational constant close to the Earth's surface, which is 9.8. GlowScript code. To the right is my GlowScript code, which has my preconditions from the experiment as well as the estimated point charge. The two assumptions I made when creating the code were to treat a long tape as though it were a point charge, with all the charge concentrated at the center of the long tape, and to assume that each U-tape I made had about the same amount of charge, evenly distributed along the length of the tape. The code also chose the code for the three arrows I created to represent the forces acted on a point charge. As you can see to the right, I also have define an E field, which represents the equation that we showed before in the main physics principles, which has Q, R, and E variables within it. Model. To the right is the model created from the GlowScript code representing the two pieces of Scotch tape presented as point charges. The orange arrows represent the electric force being opposed on the point charge by the opposite charge, and the green arrow represents the force of the gravity on the floating point charge. The model shows that the electric field, or electric force, is countering the gravitational force, causing the upper point charge to float in the air above the bottom point charge. Comparison between the model and experiment. There were both similarities and differences between my model and the experiment I conducted. The similarities between them were in the direction and effect of the forces acting on the masses. The differences between them were that the charge would have been less in magnitude from the model than the one I calculated from the experiment. Errors and possible explanations. Possible errors that could have been encountered during this lab were during the experiment and getting the data. During the experiment, I could have incorrectly measured the distance between the tapes as well as not removed the tapes fast enough to get a strong enough charge that I could measure. Questions. What if? For the what if question, if the protons had negative charges and the electrons had positive charges, the reactions between the two pieces of tape would remain the same. The pieces of tape will still repel each other because they will still have like charges regardless of whether that like charge is positive or negative. Why? For the why question, it is important to handle charged objects with care because you are currently neutrally charged. If you carelessly touch a charged object, the charged object will seek equilibrium with you and dissipate a portion of its charge within you, which can have dangerous effects. Conclusion. In conclusion, I went over the main ideas, purpose, and preconditions of this lab. I was able to explain the results of the experiment of the two pieces of Scotch tapes as well as record the data from it. I also created a GlowScript model of 2-point charges representing the two different pieces of tape. I went over possible errors and mistakes that might have occurred. I also answered the what does it mean question and the why question. Thank you for watching.